All right, let's get into section 4.2, which is powers and exponents. So our learning targets for today are to be able to write expressions using exponents and also evaluate those expressions that contain exponents. So our key terms are base and exponent, right? The base is the number that is multiplied, and the exponent tells you how many times the base is multiplied by itself. So if we look at this example over here, it's read 3 to the fourth power, right? An expression containing an exponent is considered a power, right? So the 4 is the exponent part and the 3 is the base. So this would tell me that I'm going to take my base, gotta take my base of 3 and multiply it by itself 4 times. All right, so this 3 to the fourth, if I expand that out, is 3 times 3 times 3 times 3, right? And we can evaluate that. So I can say, all right, well, 3 times 3 is 9, right? That'd be 9. So that should equal 81. Or, right, we could go in order, right? Remember, order doesn't matter when we multiply. We could go in order and say 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81, right? Either way, when we evaluate that, it should equal 81. Now, you can see that 3 to the fourth power, right? That's a pretty small base, pretty small exponent. We're already to 81 on that, right? Because repeated multiplication increases pretty fast. So we're going to have a way to use our calculator or know how to use our calculator when doing these. And we'll look at that a little bit later in the video. So this is just a table, and it gives me an expression and the translation. How do we say that, and what does it really mean when we look at that? So first of all, 2 is the same thing as 2 to the first. You don't usually see this 1 written as the exponent. It's just understood to be here, right? When I see the 2, it's understood that that is a power of 1 without even writing it. And we've seen that before when we talked about solving expressions, right? And we had x, we knew that that was the same as 1x, even though the 1 is not written there. It's understood to be there. Same with the power of 1. You typically do not see it written 2 to the first power. It's just 2. Here, when it's a second power, the exponent of 2, it can be read 2 to the second power, or you also hear that say 2 squared, right? Which means 2 times 2, which is 4. 2 to the third power can be also translated to 2 cubed, right? When the power is 3, you can say it's cubed. Power of 2, you say it's squared, right? Everything else, you just say the base to whatever the exponent is, right? So this would be 2 to the fourth. This one would be 2 to the fifth. Here would be 5 to the third power. And what that means, right? 2 to the third means I have 2 times 2 times 2, right? Which would be 8. 2 to the fourth, that means I multiply 2 by itself 4 times. 2 to the fifth, same thing. I have 2 multiplied by itself 5 times. Here, 5 to the third, right? 5 times 5 times 5, right? I multiply it by itself 3 times, okay? And I get 125 for that. Now, let's look at a calculator, and I just pulled up a picture of a TI-30, which is a pretty common calculator. It's a great calculator. If you don't have one, you're looking for one, that's a great one to buy. And we'll look at some of the buttons that are used for exponents. You've probably used this one before right here, the squared button. But the thing is that only works when it's a power of 2. For example, if I want to figure out what 5 squared is, right? First of all, we should know that. But if we want to check our answer on a calculator, I could type in 5 and then hit that x squared button, and then I hit my enter right here, or equals, and it should tell me 25. Okay. However, let's say that I wanted to calculate 7 to the fourth power. right? So 7 to the 4th power. I should know that one way to do it, I could type in 7 times 7 times 7 times 7, right? Which is a lot to type in, and then you got to count, make sure you have 4. So another way to do that is to type in 7, and then you have this little up arrow looking thing, and it's located typically, it's right above the squared button. It's called a caret key, and that's used for any power. So it's saying 7, and when you hit that, whatever you type in next is going to be the exponent. So 7 raised to the 4th, and then you can hit equals. Okay, so 7 raised to the 4th, and then you can hit equals or enter, and that should compute it for you. Now, this is the most common key for exponent, right? The caret key. But on some calculators, you'll see it as y, and then it'll have x as an exponent. This is also a caret key on some scientific calculators. You'll also see a raised to the b power on some calculators. So you have to figure out what calculator you have and what is your exponent, what is your caret key on there. Remember, I put a link in for Desmos, right, which brings you to this site here. I'm going to try to hide this real quick. So I'm going to go hide that so I can pull up this keyboard, right? And if I want to type in 7, okay, right here, here's my square, but I want a 4th power. So I hit this a raised to the b. See how that jumps up to a little exponent there, and then I can type in 4, and it tells me that's 2,401. All right, so whatever calculator you use, practice that real quick. 7 to the 4th power, it should be able to compute to 2,401, right? And remember the different keys that it could look like. It could be the caret key. It could be this y to the x power. It could be ab. If anything, just use Desmos, right? If you're still not sure on the calculator you have, use Desmos. All right. So here's another table. So we're looking at what happens if I have a negative value, right? Up here it was positive 2 raised to a power. Here we have negative 2 raised to different powers, right? So first of all, negative 2 to the first, we should know that that's just negative 2. Negative 2 to the second power would be negative 2 times negative 2. And our integer rules tell us that if I multiply negative times negative, it's actually a positive value. So whenever I square a number, it's going to be positive, right? Because it's, remember, the exponent tells me it's something times itself. So negative 2 times negative 2 would be positive 4. However, when I get down here, negative 2 times negative 2 times negative 2, that would give me negative 8. Negative 2 to the 4th power, right? Remember, negative 2 times negative 2 is 4, times negative 2 is negative 8, times negative 2 would be positive 16, right? Negative 2 to the 5th, right? Essentially, all we're doing is adding another multiplication of negative 2. So if I know this one's 16, multiply that by negative 2, should get negative 32. Negative 2 to the 6th power, that would be back to 64. So when I have a negative number with an even power, my answer should be positive. When I have a negative number to an odd power, my answer should be negative, right? Because evens, right, the negatives end up, negative times negative would be a positive, right? So I can multiply these two together and get 4, these two together and get 4. That would give me positive 16. So one thing we have to be careful on is we should know that, right? Odd powers on a negative number is negative, and even powers is going to be positive. But sometimes we just go and we rely on our calculator and we type it in. Let's say that I want to figure out negative 2 raised to the second power, right? And look what my calculator tells me. It tells me -4, right? So we know that that's not true, but we have to figure out why is my calculator telling me that. And it goes back to the order of operations, right? PEMDAS, P is parentheses, E is exponent, multiplication, division, addition, subtraction. If I look at this, there's no parentheses. So the first thing that my calculator does is the exponent, and it reads that as 2 squared, which is 4. Then it multiplies it by this negative, or -1. So it does 2 squared, which is 4, and then it applies the negative, which gives it -4. So when you are typing in your calculator, and it's a negative value, you have to put it in parentheses, right? -2 raised to the second power. So now what my calculator is doing, it does parentheses first. So it's grouping the negative with the 2 and then squaring it. Okay, so make sure that you are using parentheses, especially on the negative numbers. And we'll look at examples of that a little bit later. So 0 power, right? Anything to the 0 power is 1, okay? Except the exception is 0 to the 0 power, right? And if you type that in your calculator, right, if I were to type in 0 raised to the 0 power, that's an error. It tells me 1. Most calculators will give you an error message and say that it error, and it might even give a code as to why it's an error, but that is the exception. So 1 to the 0 power is just 1. 2 to the 0 power is 1. 3 to the 0 power is 1. 4 to the 0 power is 1. X to the 0 power is 1. -9 to the 0 power is 1, right? Anything to the 0 power is 1. And the reason is because it's like it's not even there. So if I have this expression, let's say that I have 2x squared y to the 0 power, right? Really, it's like I have none of these, right? I have no y values there. So if that's equal to 0, then it cancels out this whole part of the term. That's why it's just 1, right? Because when you multiply by 1, right, we talked about that, the multiplicative identity keeps it the same, is just 1. So anything to the 0 power is 1. All right, so let's go the other way. We looked at, okay, if I have 5 to the 3rd power, that's 5 times 5 times 5. Let's see what we have here, and see if we can write these as an exponent or a power term. So look here, I have 11 as my base, and it's multiplied together 3 times. Here, 5. All right, well, I could write it as 5, or I could write that as 5 to the 1st power. Here I have a base of a, and there's 4 of them, so a to the 4th. Here, 4 is my base, multiplied together 3 times. -v, there's 1, 2, 3, 4. Okay, now let's talk about this. A negative value to a positive for exponent, even exponent. My value should be, it'll end up being positive, right? Anything to an even power is going to be positive. Now, number 11 is a little bit different because I have 2 different bases, right? I have 2, and there's 1, 2, 3, 4, 5 of them. And I also have t, and there's 2 of them. So 2 to the 5th times t squared. Pause it and see if you can do the evens 2 through 12. So pause here, and I'll see you back in a minute. All right, let's see how you did here. Okay, first off, number 2 should be 2 to the 8th. And if you put 2 to the 9th, you might have included this 2, which isn't supposed to be there. That's just identifying its number 2. And then there's 1, 2, 3, 4, 5, 6, 7, 8. Multiplied together, so base of 2, exponent of 8. -4 times -4 would be -4 squared, right, which should be positive 16 if we were evaluating. Here we have n to the fifth. Here, really, this is b times b times b times b times b times b, right? So b to the sixth power. Number 10, we have two bases, right? We have x squared and we have z to the third. Number 12, there's three bases, right? We have m to the third, n or n to the first, right? You could have written a 1 there. You don't need it, but you could write a 1 there. And then we have p squared. All right, now evaluate, okay? And again, when we evaluate, when we're plugging in values, it's going to be very important to use parentheses, especially when we have this negative here that we could be inserting. So number 17, right? I have this y raised to the x power. So I'm going to insert y, which is negative 2, raised to the value of x, which is 3, right? So I can use my calculator, or I just want to know that we understand that this is negative 2 times negative 2 times negative 2. So use your calculator, and you should get negative 8, right? Negative odd power, right? Because every two of them is a positive, so I end up with that negative riding out to the end. And again, use your calculator. Make sure that you can compute that correctly if you're not doing it by hand. 19. So I see z squared, so I know it's squared, so I know my answer is going to be positive no matter what. But I'm going to take this 4 and insert it into the z. 4 squared, right, which is really 4 times 4, should be 16. 9 raised to the power of x, right, which is 3. So that would be 9 times 9 times 9, right? And we get 9 times 9 is 81. 81 times 9 should be 729. All right, and again, calculator, make sure you can compute that. And I want you to work on the even. So pause here and work on 18, 20, and 22. All right, number 18, nothing to plug in, right? None of the variables in this problem, just 51 to the 0. We should know anything to the 0 is just 1. We take the 3 and plug it in for x, so 3 squared, which is 3 times 3, should get 9. Number 22, when I plug in z, right, it's 4 squared times 2 squared. So 4 times 4 times 2 times 2, right? 16 times 4 should get 64 when we evaluate that expression. All right, your practice is on page 155. On a separate sheet of paper, do the following problems. Notice 70, 72, 73, those are review questions, right? Make sure you're keeping up on other concepts, as they will come back up or be used to expand on in other lessons in Chapter 4. As always, if you have any questions, please shoot me an email. I hope you have a great day.